Question 550. This question is to evaluate this definite integral. If we have same lower limits and same upper limits, then we can always combine these integrands and simplify them. Okay, let's try this. So this integral is equal to, from -4 to 4, we have 2x cubed plus 4x squared minus 3x minus 2 minus 2 times 2x squared. So that's minus 4x squared minus 2 times minus 1. That's plus 2, right? So we have 4x squared minus 4x squared. Cancel them out. Minus 2 plus 2, right? So that is equal to integral from -4 to 4. We have 2x cubed minus 3x dx, right? Now, if we look at this function right here, that's an odd function because this term has power 3, odd power. This term has power 1, right? Odd power. If each of these terms is odd, then the function is odd, right? Odd function is always symmetric about the origin, right? Since this is definite integral from -4 to 4, this value must be equal to 0, right? So the answer is equal to 0. Think about this graph right here. If we have an odd function from -4 to 4, see here's a -4, here is 4. Let's say we have this type of function. Then the area of this part right here is equal to the area of this part right here, right? But when we find the value of definite integral, this is going to be positive area, and this is going to be negative area, right? So sum of these two reasons right here, sum of these two values, that's going to be equal to 0, right? So if this function is odd from -a to a, then this definite integral is always equal to 0. Question 573. Let f be the function defined by f of x is equal to this definite integral. At what values of x does f have a relative minimum? In order to find the relative minimum of f, we have to find the derivative of f, right? So let's differentiate this function right over here. F prime x is equal to, the function f is a definite integral, right? So derivative of this is, what we have to do is we have to substitute 2x for t, then multiply by the derivative of 2x, right? That's Fundamental Theorem of Calculus, right? So let's substitute 2x for t. That's going to be 2x cubed minus 2 times 2x squared times derivative of 2x, 2, right? So let's simplify this. We have 2 here, 2 cubed, that's 8, x cubed, minus 2 times 2 squared, that's 8x squared. Let's factor 8x squared. So that's going to be 16x squared x minus 1, right? That's f prime of x, and set that is equal to 0. Then our critical points are x equals 0 and 1, right? And we're going to perform the first derivative test. So here 0, here 1, f prime, right? Substitute any value less than 0, maybe -1. Well, this is x squared, right? So don't worry about this. This is always positive. So if we substitute -1 here, then that's going to be -1 minus 1, -2. Negative, right? So here we have negative. If we substitute a value from between 0 and 1, probably 0.5. Then that's going to be 0.5. That's going to be also negative, right? So here we have negative. What if we plug in a value greater than 1? Value greater than 1, let's say 2. 2 minus 1 is a positive, right? So here we have a positive. So function f decrease here, but increase here. So we do have a relative minimum at x equal 1, right? So at what value of x does f have a relative minimum? X is equal to 1. Question 575. We have a function f right over here, and the question is, at what values of x does the graph of f have a point of inflection? We know that in order to find the point of inflection, basically we have to find the second derivative of the function f, right? So let's differentiate the function f right here. F prime is equal to, this is a definite integral, right? So we have to substitute 2x for t first and multiply by the derivative of 2x, chain rule, right? So let's do that. So 2x cubed minus 2 times 2x squared times the derivative of 2x, which is 2, right? So that is equal to 2 times, if we simplify inside the parentheses, that's going to be 8x cubed minus 2 times 2 squared, that's also 8x squared, right? So that is equal to, if we factor out 8, that's going to be 2 times 8, 16x cubed minus x squared, right? That's f prime. Now f double prime, the second derivative, is equal to 16 times 3x squared minus 2x, right? And we're going to set that is equal to 0. And we're going to have to find the value of x where f double prime is equal to 0, right? So let's factor out x. Then that's going to be 3x minus 2, right? That is equal to 0. So second derivative is equal to 0 when x is equal to 0, or x is equal to 2 over 3, right? Now let's test the second derivative, the concavity test, right? So here we have 0, 2 over 3, f double prime, right? If we substitute -1 for x, then that's going to be negative times negative. So we have a positive here. If we substitute, let's say 1 over 3, I guess. So erase this, substitute 1 over 3. Then that's going to be positive times negative, right? Positive times negative. So that's going to be equal to negative on this interval. If we substitute maybe 1, then that's going to be 16 times 1, positive, 3 minus 2, positive. So that's going to be positive, right? Since the sign of f double prime changes at x equals 0 and at x equals 2 over 3, from positive to negative here, negative to positive here, right? So we have 2 points of inflection, and they are x equal to 0 and x is equal to 2 over 3. Okay? Question 586. What is the value of limit right over here? Okay, let's substitute 1 for x first. So that is equal to denominator, that's going to be 1 squared minus 1, which is equal to 0. Numerator, that's going to be 0 to 1 minus 1, that's a 0, right? And we have a square root t squared plus 9 dt. So denominator is equal to 0. Numerator, if we have definite integral from 0 to 0, that's 0, right? So this is indeterminate form. Then we have to apply the L'Hopital's rule to find this limit, right? So let's apply L'Hopital's rule. That's going to be equal to limit as x approaches 1. Derivative of numerator, that's going to be square root. We have to substitute x minus 1 for t, right? So x minus 1 squared plus 9, right? Times derivative of x minus 1, that is equal to 1, right? Now the derivative of denominator, x squared minus 1, that's 2x. Now substitute 1 for x. So numerator we have, if we substitute 1 here, that's going to be 0 squared plus 9. So square root of 9. And if we substitute 1 here, that's going to be 2, right? So square root of 9, that's a 3. Denominator 2. The answer is 3 over 2. Question 609. A particle moves on the x-axis so that at any time t is greater than or equal to 0, its position, velocity, and acceleration are given by x of t, v of t, and a of t, respectively. Which of the following gives the average velocity of the particle from time t is equal to t is equal to 6? Okay, we know that velocity is x prime t, right? The slope of tangent line. Especially when the question is asking us to find average velocity, that's going to be equal to slope of a secant line that passes through when t is equal to 2 and t is equal to 6, right? So that's going to be equal to y2 minus y1, which is equal to x of 6 minus x of 2 over 6 minus 2, x2 minus x1, right? So that's going to be equal to x of 6 minus x of 2 over 4. That's our average velocity from the time t is equal to 2 to t is equal to 6, right? So this is our average velocity. Also, we can use the definite integral. When we use velocity, then average velocity can be written as 1 over b minus a, in this case is 6 minus 2, definite integral from 2 to 6, right? v of t dt. That's also average velocity, right? So that is equal to 1 over 4 integral from 2 to 6 v of t dt. So this is also average velocity from time t is equal to 2 to t is equal to 6. So the answer must be D. Question 615. The function f is given by, right over here, on which of the following intervals is the graph of f both decreasing and concave up? Okay, we know that the function f is decreasing when f prime is negative, and it is concave up when f double prime is positive, right? So basically, we're going to have to find the first and second derivative of f. Before we find our first derivative, it looks like this expression is factorable, right? This expression can be factored. So let's factor this expression first. That's going to be equal to 2t, 1t, 1. We must have a negative t here, so minus 1 here, plus 1 here, right? So f of x is equal to definite integral from 1 to 2x plus 1, and expression here is 2t plus 1, t minus 1 here, right, with the dt. Now f prime is equal to, we're going to have to substitute 2x plus 1 for t and multiply by the derivative of 2x plus 1, which is equal to 2, right? So we're going to substitute 2x plus 1 and 2x plus 1 minus 1 times derivative of 2x plus 1, 2, right? So let's simplify this. That's 4x plus 2, so 4x plus 3, right? 4x plus 3. Here we have 2x, so 2x times 2. If we expand this expression, that's going to be 4x times 4x, 16x squared. 4x times 3, that's 12x. So far so good. Now let's find the second derivative. F double prime x is equal to 32x plus 12, right? Now we have to find the value of x where first derivative is equal to 0 and second derivative is equal to 0, right? Then after that, we're going to perform the first and concavity test. So I'm going to let this is equal to 0 right here, because this expression is factored already, right? So f prime is equal to 0 when x is equal to negative 3 over 4 or 0, right? F double prime is equal to 0 when, okay, let's solve this. 32x is equal to negative 12, and this is divided by 4, so 4, 3, 4, 8. So when x is equal to negative 3 over 8, right? Now we're going to test. So draw the line here. Okay, here f prime, here f double prime. F prime is equal to 0 when x is equal to negative 3 over 4 and when x is equal to 0. So we're going to test these intervals. F double prime is equal to 0 when x is equal to negative 3 over 8. So let's say here is a negative 3 over 8. Okay, when x is negative 1, let's say x is negative 1 here. Negative 1, that's going to be negative times negative, right? So that's going to be positive here. If we substitute negative 3 over 8, I guess, then that's going to be negative 3 over 8. Negative 3 over 8. Then that's going to be positive times negative, right? That's negative. If we substitute 1, that's going to be positive, right? Here, for f double prime, let's substitute negative 1. Then that's negative. If we substitute, I guess, 0, then that's positive, right? That's a positive. So we have to find the interval where f prime is negative, f double prime, and f double prime is positive, right? That's right over here, right? F prime is negative, f double prime is positive. So the answer must be from negative 3 over 8 to 0. The answer is C, right?